so we're going to have these memorized in such a way that I could call like 4 to the third out, and within 10 seconds, without multiplying it, working it out on your paper, you can just tell me 4 to the third 64. You can tell me that 2 to the fifth is 32, that you're going to know them. And so I need you to make flashcards, and you can get you some index cards. You can even cut those in half and make you some flashcards, and we need those due one day this week. I'll let y'all decide, and then we'll have our exponents test maybe Friday. Does that sound good? But I want you to know them. Memorize them like you memorized your multiplication tables. After you get your flashcards made, just go through the stack, and like you'll have your problem on one side, answer on the other, and you'll just go through and make a stack of I know and I don't know, and I know and I don't know. And then once you got all the knows, you pick up the don't knows, and you start back through those again until there's nothing left in the I don't know, and then go back through it again. That's the only way that you can memorize. This is a 100-point test. It'd be a great opportunity to have a really good grade. You know, it could also mess you up. Don't let it do that. But this is it. There's not going to be any problems except for this right here. It's going to be all there is to it, okay? All right. So if you look in your packet, I've already run this off for you so that you didn't have to write so much down. But this is the base, and then this is the exponent, and then this is our answer. So 2 to the third is 8. Of course, that just means 2 times 2 times 2. Has nothing to do with 2 times 3. Would you find this button or this button on your calculator? That's your exponent button. Raise your hand if you can't find it, and I will help you. Does anybody need any help finding that? Oh, anybody else? Everybody got it? Okay. All right, so let's look at these problems right here. Let's figure it out without using our calculator, and then we'll use that button. If 2 to the fifth is 32, then double that to get 2 to the sixth. So that would be double 32. What would it be?
64.
64. All right, double that 64 and get 2 to the seventh. 64 and 64.
128.
128. Good. And so double that to get 2 to the 8.
312.
256. Okay. All right, use your calculator and see if you can do 5 to the third. You should get 125. Let's do this one in our head. Anything to the fourth power, you just square it twice. So what's 3 squared?
9.
Squared.
81.
81. And anything to the first power is itself. That's not too bad. All right, with or without your calculator, do these. And we'll do them for dollars. So Emily, what is 2 to the 6th?
64.
Very good. Very good. All right, and then what is 4 to the third? It is the same thing. Very good. Notice those are alike. And then 3 to the third?
3 times 3 is 9. 9 times 3 is 27.
And anything to the first power is itself. All right, let's just look at the product rule. That was our main focus for today. If I'm multiplying the bases, then I keep the base the same, and I add the exponents. Have y'all found this page right here? No? Oh, yes? Okay. So you keep the base the same and add the exponents. For example, if I have x squared times x to the third, I keep the base the same and I add the exponents. Even if it's numbers, if I have 2 squared times 2 to the third, notice this, I keep the base the same and I add the exponents. This does not become a 4. That didn't become a 2x. Or x squared. I kept the base the same. I kept the base the same and just added the exponents. Now, this is a coefficient, number multiplied from the variable. This is a coefficient, right? Multiplying in front of the variable. 4 times 3 is 12. And then if I'm looking at my x's here, x to the fifth times x to the third, I keep my base the same, and I just add the exponents. Now, I didn't apply an exponents rule here to 4 and 3 because they didn't have like bases. There weren't 2 3s or 2 4s. 4 times 3 is just 12. I just simplified that, okay? So I didn't apply any rules of exponents there. Don't let that confuse you. All right, let's look here. Let's fill in the blank. All right, so I'd have 2 to the third times 2 to the fourth would give me a 2 to the what? 7. If 2 to the fifth is 32, 2 to the sixth is 64, so 2 to the seventh is
128.
128. You're going to go all the way to simplify that, okay? All right, now 8 to the first times 8 to the third. Notice this does not become 64. I keep my base the same. And I just add those exponents. All right, what is 8 to the fourth? Got a calculator, use it.
56.
I got 4,096.
4096 is correct. 8 to the fourth is 4096. All right, now these problems and this last problem differ. Why?
Because the coefficients are different.
The bases are different. I cannot apply a rule of exponents if the bases are different. So all I can do is use my my exponent button and find what is 4 to the 7th. So you guys do that for me. 4 to the 7th.
16,384.
16,000?
Yeah.
400.
And 80. I mean, 380.
384. All right, thank you. All right, do the same thing with 9 to the 6th. That's going to be a big number. 9 to the 6th. 448. 441. Whoops. Oh, that makes sense because 9 times 9 is 81. Is this what you said? Okay. Multiply those together, and you get a very large number. What is it?
8,707,129,144.
What's the last part?
344.
Like this? Does anybody agree? Use your
Yes.
calculator. All right, now this problem did not use the rules of exponents because it did not have like bases. All right, let's look at these. I have y squared and y to the fifth, so I'll keep the base the same and add the exponents. When my bases are variables, or in this case, when my bases are numbers, I keep the base the same. This does not become 25. Say 5 times 5, okay? I keep the base the same, and I use a rule which said I'm going to add the exponents. That's as far as I can go because I really don't know what M and P are. Once I find those out, I can plug them in, but I don't know. All right, you guys do these 4 problems for dollars. Okay, what's this one? 3 to the 6th gives me 17. And the next one will be 8 to the, which is 196 again. And then the next one is
C to the 9th power.
the 9th, and we don't know what Z is. And then the last one is, that's right. Is this easy stuff? Yes. Alright, we've talked about a monomial before. We'll do it again. A monomial is a number, a variable, or the product of a number with one or more variables. For example, 7. It's a constant, but it's also a term or a monomial. Y squared is just got a variable to an exponent. It could just be x, or it could be like this. This is one term. It has a coefficient and 3 variables, but they're all multiplied together. So this is one term. It's like having a first name, a last name. excuse me, a first name, a middle name, a last name, and a junior or something. This is all just one term. So to simplify, when you're multiplying, we remove the parentheses by multiplying and putting all like terms together. Think about it like this. You're gonna put all the A's together, all the B's together, all the C's together, all the X's together, or like this one, all the T's together. Alright, so 5 times negative 30, that has nothing to do with exponents. They're not like bases. We can't add the exponents, but they are coefficients, so we can multiply them together. And then when I put t to the first multiplied by t squared, I get t to the what? Don't forget this one. 1 plus 2 is 3. And let me warn you that that 1 will not be written there in the book. You'll just have to know it's there, okay? Alright, same rule applies here. Negative 4 times negative 1 times positive 3 gives me
12.
12. And we'll put all the a's together. A squared, a to the first, and there's no a here, so that would give me an a to the
Third.
good. B to the
Third.
third, and C
Fourth.
to the fourth. Put all the like ones together. Multiplying, so you add the exponents. Alright, you guys do these two. Alright, what's the first one gonna give us?
The first one is going to give you 180 m cubed p squared.
That's right. Okay, and the next one?
160 xy to the first, c to the third.
X to the what? X to the first, Y to the,
First, c to
well, I've got a Y here and a Y there.
y to the second,
And Z to the third, that's right. Does everybody understand? Alright, let's look in our textbook. Lesson 8.1. We want to look at example 3, which is on page 372. As you guys in biology know, bacteria multiply exponentially, very quickly. All they have to do is split in two and form another, what is that called? It starts with M. Mitosis, meiosis, what's the word that goes there?
Mitosis.
Y'all just pick one?
Yeah.
Oh, alright. Suppose that a colony of bacteria doubles in size every hour. If the colony contains 100 bacteria at noon, how many bacteria will the colony contain at 3 p.m. and 5 p.m. of the same day? As far as exponential equations go, when you're dealing with exponential growth and decay, the formula looks like this. You'll have your initial amount, you'll have your multiplier, and then you'll have your power, which usually has to do with time. And so in this particular problem, there were 1,000 bacteria to begin with, and if they're doubling every hour, that means 2, and this is the number of hours that we use. So there's our equation. So from 12 until 3 was 3 hours. If they're doubling every hour, how many times have they doubled? They've doubled 3 times. And what is 2 to the third? 2 times 2 times 2. 8 times 1,000 would be 8,000 bacteria in just 3 hours. On the other hand, I think it said the next one we would do at 5 p.m. Well, from 12 until 5 is 5 hours. And I think I've said this several times. What's 2 to the 5th? I keep trying to say it so we can memorize it. What's 2 to the 5th?
32.
32 times 1,000, 32,000. So this morning, if there were bacteria on your desk that were doubling every hour, if there had been 1,000 of them by this time of day, how many bacteria would there be? If there had been 1,000 bacteria on your desk this morning, the top of your desk, and we get here at 7:30, so 8:30, 9:30, 10:30, 11:30, 12:30, 1:30, 2:30, 7 hours later, if they were doubling, how many bacteria would be on that desk if we didn't clean it? And by the way, I haven't.
128,000.
128,000 of them. So if you wanna lay your head down on your desk and, you know, lick the top of it or something like that, that'd be kinda disgusting, but, that's the way bacteria spread, right? That's how we get sick. Yes.
Not to mention the weekend.
Oh yeah, it grew all the weekend because I didn't clean them then either. All right, let's look at example 5, which we will find on page 373. The volume of a right rectangular prism can be found by using the formula volume is equal to length times width times height. All right, so we will draw us a figure, a rectangular prism. And we'll connect the dots. Connect the vertices. Make our figure look 3D. And it tells us here that the length is 2xy, that the width is 3xy, and that the height is 6xyz. So the volume is equal to the length times the width times the height. So we would have 2xy multiplied by 3xy multiplied by 6xyz. And we would apply the property that we've learned today. Multiply the coefficients together. 2 times 3 times 6 would give you what?
36.
36. The x's together would give you x to the, remember the ones aren't written there, but they're there, to the third. Y to the
Third.
the same thing, and z is all by itself to the first power. And that would be whatever the units are cubed because it's volume. You might have a question. All right, let's look at this one. Suppose that a bacterial colony doubles in size every half hour. How many times would that be in 1 hour? If the colony contains 2,000 bacteria at 10 a.m., how many bacteria will the colony contain at 1 p.m. and 2 p.m.? All right, remember, we have an initial amount. We have a multiplier. And this T stands for time. All right, what is the initial amount of bacteria in the problem? How many? 2,000, right, good. And then it tells us here that the bacteria are doubling, and so that's the multiplier. And this is twice every hour. This problem's a little different because it's doubling every 30 minutes. And so from 10 a.m. to 1 p.m. is how many hours? 11, 12, 1. So it's been 3 hours, but if it's doubling every 30 minutes, then it's doubled how many times? 6. Okay. So we'll have 2,000 times 2 to the 6th power. What's 2 to the 5th? Y'all remember yet? 32. So what's 2 to the 6th?
64.
So what is 64 times 2,000?
64.
Times 2,000.
128,000.
128,000 bacteria.
That's the amount of germs I want to say.
Yes. Scary. All right. So now let's do 2 p.m. So y is equal to the initial amount. The multiplier is 2 because it's doubling every half hour, so twice an hour. And now I've added an hour, right? So this will become what? 4 hours. So y is 2,000 times 2 to the 8th. All right, 2 to the 5th is 32. 2 to the 6th is, 2 to the 5th is 32. So 2 to the 6th is 64. 2 to the 7th is 128. So 2 to the 8th is
256.
so 2,000 times 256. How many bacteria in 4 hours?
512,000.
Wow. from. Alrighty. Alright, let's look on page 375. You guys recognize a food chain? Seen one of those in biology maybe? The science book. On page 375 it says food chains explain why even small organisms affect much larger ones. The following is an approximation of how a food chain works. A whale might eat 10 seals per day. Ever seen those cute videos on the Discovery Channel? Poor little seal sitting up on the ice and all of a sudden a whale eats 10 of them per day. A seal might eat 100 pounds of fish per day. 100 pounds of fish per day? Goodness. All right. And each pound of fish might eat 10 pounds of zooplankton per day. And each pound of zooplankton might eat 10 pounds of algae per day. All right, so we're going to answer these questions. We're going to express our answers as powers of 10 because if you'll notice, everything up there was all on base 10. All right, so the number of seals needed to sustain a whale. The first statement says a whale might eat 10 seals per day. So number 61, if I'm expressing this as powers of 10, that would be 10 to the first. Now, a whale has eaten 10 seals. So number 62, I'm on page 375. Number 62 says the number of pounds of fish needed to sustain a whale. Well, we know from the second statement there that a seal needs to eat 10 squared or 100 pounds of fish per day, and the whale is going to eat 10 seals, and they need 100 pounds of fish per day. So how many pounds of fish would that give me to sustain a whale? 10 to the first times 10 squared would be 10 to the third. It's going to take 1,000 pounds of fish to sustain a whale for a day. All right, and then it says on number 63, the number of pounds of zooplankton needed to sustain a whale. Okay, well, we already know that it's going to take 1,000 fish, excuse me, and those 1,000 fish are going to eat 10 pounds of zooplankton. And so how many pounds of zooplankton are needed to sustain, go back and sustain the whale would be 10 to the fourth, which would be 10,000. And number 64 says, what's the number of pounds of algae needed to sustain a whale? Well, we know it needs 10 to the fourth pounds of zooplankton, and each of those zooplankton needs 10 pounds of algae, so that would be 10 to the fifth, which is how much? 100,000 pounds of zooplankton needed to sustain a whale per day. So what happens if the algae is wiped out, or if the zooplankton's wiped out, or the fish population is killed out, or poachers are killing all the seals? What happens to all the rest of them?
They're gonna die.
They're going to starve. All right. This is your assignment. Y'all can go ahead and get started on that.